So let's get started. I think people will join. So good afternoon, everyone. Today we're going to discuss on improving, digital construction projects with digital technology. So there's a webinar topic. Yeah. So agenda for today's discussion is first I'll introduce today's specs. Before that, so my name is Dinesh. I did my graduation in civil engineering and then went on to do my master's in construction project management from Rick School of Built Environment. And I've been working on digital technologies and trying to bring digital transformation in construction industry for the past few years. And so that's about me. And so our agenda for this presentation here is first I'll just give a brief about our company Desobex and the key challenges of industrial construction projects, and then digital implementation in all stages of the project. And then we'll go into reality capture and its use cases in industrial projects. And then final, what is digital twin, and then Gronlund Manager, which is an asset management platform for the operation and maintenance, and conclusion. So to start with, Desobex Desobex is an digital engineering organization who is working towards delivering the entire life cycle by implementing the digital integration into the CIC industry. So basically, we do provide services throughout the life cycle of the building life cycle. So that's a design stage, construction stage, and the operation and maintenance stage, and the renovation stage. At each phase of the project, we have different services to be provided, and so our mission is enable the digital adoption and integration of technology for target value design. And our long-term vision is to have the sustainable built environment. So we are headquartered in Bangalore, India, and we have branch offices in Chennai, Hyderabad, and Hubli, and an international office in Stockholm, Sweden, where we serve the European clients. And we have customers from all over the globe, and so we serve on different customer segments. So this is a nice this very prestigious as an organization point of view for us. So we are the first company in the world and only the company in India to have this BSI kite mark, ISO 19650 certified. So basically, ISO 19650 is an global BIM standard, which gives us the guidelines and sets us the digital framework for the project delivery phase. So this code book, we've been certified, and we are periodically getting certified based on the audits. And then we do serve customer segment, hotel, construct, corporate real estate, residential, airports, and then warehouses, factories, and retail and infrastructure projects as well. So this team, very young and dynamic team, who is working towards same vision and mission of that organization towards the digital transformation by implementing digital technologies in the AC industry. We have civil engineers, architects, and then mechanical engineers, and all certified on various licenses like Autodesk certified and IGBC, and people from RICS and PMI, So that's the strength and the capability of our team, and we have a good bandwidth to deliver projects all over the globe. We basically have three verticals: the digital design management, digital project management, and digital asset management. So under digital design management, we do serve, convert 2D to 3D models, all the services, architectural structure, MEP, F, and clash coordination, clash detection and coordination, then BIM-based pre-construction services, and digital project management, digital information plans based on the ISO 19650 frame, and then technical due diligence for any property to take in, and then setting up the digital labs like 4D, 5D, and then virtual reality and augmented reality. And then under digital asset management, we do have the scan to bin services. I'll explain about the scan to bin in the later part of my presentation, and the energy and maintenance management, and then asset management with the help of the Gronlund manager. So now, I'd like to give a little more deep on under each vertical, what all services that we provide. Starting from the detailed design management, we do have the various inputs that comes like 2D and then drawings and then non-geometrical data. We do develop the 3D geometric models, and then based on the framework that's been set as per ISO 19650. And then with the help of once the 3D model is ready, then you can perform the various analysis and practices with this model. That is starting with do the clash coordination and resolve all the clashes at the detailed design stage itself before the construction begins. And then once the model is ready, you can actually pull out the quantities and then cost, which will be helpful for the procurement. And before issuing the procurement, the model is ready, and then you get all the quantities. And then shop drawings, as told, once the model is clash free, then you extract the shop drawings, work on shop drawings, and issue it for the construction as GFC to execute at site. And then 4D and 5D, this I will come back to in my presentation, where I'll explain about 4D and 5D services. And then digital project management. So we do actually support the client in through the project lifecycle with this service, starting with briefing and stage and design, and then construction, and then operation. Starting with brief, we do set up the certain documents as per ISO 19650 to state the entire requirements of the project, and then the procedures, how each information is being produced and reviewed and then taken forward. That happens to two-phase briefing and then detailed design phase. And then while happening the design phase, we do the model auditing, clash coordination, support in clash coordination activities, who is performing that, and then validating quantities and all aspect before procurement or construction begins. And during the construction stage, as told, 4D and 5D simulation throughout the construction phase, and construction progress monitoring, this digital construction progress monitoring. This I'll explain in my later part of the presentation, how digital construction progress monitoring will help in the projects. And as built operation as a handover, so we do validate the models that is being sent for the site to construct, and then update as per the as-built conditions. And in detail design, that's about digital project management. And under digital asset management, so there's a physical building, and then you do have to convert this into a digital twin before it goes into the asset management as an enriched BIM model. So that's with the help of laser scanning, we do export, we do capture the existing conditions and then create a 3D model, and then use this model, add all the asset information, and enrich all the non-geometrical information, and then integrate with IOS and BMS data and everything, and then take this to the operation and maintenance, and set up set management and energy management, building analytics, and then maintenance management. All this, we have a platform called Gronlund Manager, where we provide entire asset management services. That's about Desopex. So we can quickly start with our topic for today. That's improving industrial construction projects with digital technologies. There are many technologies that's been in industry now for a lot of involvement in digital transformation, but I can still say it is going at a low pace in terms of digital adoption in construction industry. So starting with, I'd like to put some key challenges in large scale projects. So technology adoption as a my interest that I would like to put this point as first, because our industry is very slow in terms of adopting to digital technologies. If you see, if you compare to other industries, they are way ahead with digital. Well, unless there is a prototype, or unless there is something ready and then the next phase begins. So they are into that digital advance, but the same way we have to move towards the digital adoption in our industry. And then comes to the traditional workflow, where a lot of efforts and time during the construction documentation stage, where the effect of time and cost of design change is high. So this phase has to be moved toward a pre-post, like you have to do this kind of activities at the detailed design stage, where you can impact time and then cost of design change is very low. That's where you have to spend a lot of time so that the model and then everything is ready, then you do the procurement and then take it to the construction stage. So this, if you want to get deep, you can refer to the McLeamy curve, where Patrick, it's clearly explained how BIM workflow is helping a lot of projects compared to the traditional workflow. And comes to information management, the information production or management, it's everybody is working in silos, and then there's no structured information management framework. So there's a much need for a structured information management framework to bring everybody onto the same platform. So that happens through setting up this common data environment. Let's talk later in the part of presentation on common data environment. And there's still a lot of places we see working on 2D drawings and missing out the major advantages of BIM. That's virtual space coordination or virtual collision reviews of 4D and 5D. So because if you see virtual collision, anything that occurs on site, it takes time and then a lot of cost for rework. So all these has to be minimized or reduced to zero with the help of developing 3D geometry models, and then having this review of models before even construction starts. Then validating the project schedule is a challenging task. Yes, we do prepare project schedules, and this based on the imagination, but nothing can be visually seen and then planned. So that's where the 4D and 5D is come into the picture, where you can actually link schedule to enter a model that has been developed, and then see the simulation and then validate the schedule. If there is anything that has been missed on modeling aspect, or any particular activity that has been missed, but you see it in the model, this actually validates schedule and then gives us a realistic schedule to go ahead and then continuously progress, update the schedules. And then next, I think many would have not accept this statement, but it's a fact. As-built documentation, in general, GFC drawings have been submitted as an as-built, just by changing the title. But in few places they do update manually, but even that's not the accurate or not the right way to do it. So we have the latest technologies like reality capture technology. We use the laser scanners to capture the as-built conditions and verify the developed BIM model, and then update the model as per the site conditions. So that's an interesting digital technology that is being implemented throughout the construction now. And the last but not least, it's very important challenge that there's a loss of data or unavailability of the as-built drawings or the latest as-built drawings for any existing property. So there's 10-year or 15-year-old or even the 5-year-old building sometimes doesn't have the present as built drawings, or during this 10 to 15 years there might be a lot of change in the floor plans, or there are a lot of or even the facility they would have changed into different as per the needs, but all those things have not been updated into the drawings because there's no model. If you keep updating on the 2D drawings that you have at a certain stage, the drawing becomes like club. You can't even understand what that drawing is. So basically, you cannot update on a 2D what it is because you have the sheets with you to update. So that's where you need to have a model, or if most of the old projects don't have the developed 3D model. So that's where again reality capture comes into the picture, where we can capture the existing property and create an 3D model of existing physical facility, and then generate the required floor plan, sectional views, and all those aspects. Then coming to digital implementation. So there are very few projects that has implemented through entire process that I'm talking about, but when we start with there are a lot of digital technologies at each stage. I'll just take you through how these digital technologies will be helpful, and how it has to be implemented. We have to have a certain framework that has to be set up. Starting with the pre-construction stage, as we said, that you need to have this framework for a project for the entire delivery phase of the project. So you have to, it's like we have to set up this documents like PIR, EIR, and PEP. So they are actually project information requirements, exchange information requirements, and then BIM execution plans. So these documents will have the entire information of the project, that actually the client requirements, and what is the timelines, and how this is going to be executed. And each stakeholder or who is involved in this project, they actually put it down on paper, that how each information is being produced, and production of each information is happened. So that's something brings us a lot of clarity in what it is required, and how it is going to be done, and who is going to be done, and when it is going to be done. So these things will be very clear before even we start with any of these activities. And then as I was telling, a lot of people still working on silos, and then you need a proper information management platform, document sharing or information sharing. So that's where common data environment. So common data environment is it's a platform where everybody can have access to the right information in right time. And right information is very important because you need to take the right information before you start executing anything on site. So, and even for the coordination or reviewing between the stakeholders, so all of them have to be in single platform to understand how everything works. It has to be a coordinated system to design. Just not that one person is working. There's an architect, there's a structural separate, and then you have MVPs. Each discipline might have each different stakeholder that has been involved in the project. So it's important to bring everybody into one platform and work on that common data environment. So we'll have a little more about common data environment in coming slides. And managing of 3D models and clash detection is what I was, once the models are developed, you have to coordinate with all the other services and make sure that model is clash free, and before it goes to the construction site for an execution. So, and then comes 4D and 5D simulation. This is with respect to the model and then time. So 4D is something that you add your project schedule to the developed model, and then run the virtual construction and see see if there is any errors in the schedule or if there's any error in the model, because you're getting quantities from the model and the model has to be accurate. That's how this 5D, the cost element, will be added to this particular aspect. And virtual reality and augmented reality, again, it's very buzzwords here in industry now. So with the help of virtual reality, it's you can actually have headset and then walk through your entire building even before or it is gone for construction. You walk through an entire property and then review it, and those very valid inputs can be given. Even a client can actually wear it and then review the entire building and all those. And even for the clash coordination, you can review and use the markups and all those aspects in the virtual reality. And when it comes to augmented reality, so augmented reality is something with the real experience with the, it'll be with the real world, where you can see your developed facility or factory in a site. So you can actually see how it is going to come up in a real world using these augmented reality technologies. And construction stage and handover. So it's very important that we set up a lot of processes at the pre-construction stage, that it has to be taken and it has to be followed throughout the construction stage. I know we do develop model and we do make sure clash core everything model is free, and then you send we send the drawings to the site to execute. But and it has to be we have to make sure that it is being executed as per the model. If not, it has to be captured as per the site conditions later to and update the model. So one thing is we have to manage the same setup that has been followed and set up the common data environment throughout the project. And then digital construction progress monitoring with reality capture. This very interesting technology or service that I would say. So where there's okay, we keep updating what the amount of work that is being done. It's all again on what you see on the site, and then there's no audit that's being done. Is it exactly no? Executed as per the drawings? We do have to do the manual measurements and all those. That's where reality capture, you can actually capture the work that is being performed and then compare it with the model and see what is planned and what is actually is being executed. And that this actual information from the site will help us in running the entire 4D and 5D simulation throughout the project life cycle, where you can virtually show this is what we have planned and this is what we have achieved. And not just with respect to the work that has been done, it's the way even the cost is linked to it, and this is what it has been budgeted and this is what it's been spent. So all this will be analyzed with real data that is being captured with reality capture, and take it forward for this. And I was just telling about this as-built documentation. It's very important to not just submit GFCs as built. It has to be actually updated to as built. So this can be done with reality capture, where we have to capture the existing conditions or as built conditions, and then compare it with the model, and then update the model as per the site conditions. So now you actually have the built asset as a digital asset with you. So that's very important. Digital twin, it is exactly what the previous point tells us. So what is built, and then you have the exact digital built asset, and then you add in all non-geometrical information to it and make it as a digital twin and take it for an operation and maintenance. So we'll talk about the digital twin and operation and maintenance in the later part of my presentation. And existing projects, yes. So as I already gave a touch on that, why it is required, because most of the retrofit projects, they need to have the present as built conditions or as built drawings, so that they can plan on what needs to be done, what floor plans, or if there is any how what sections has to be used, and how I have to use the space and all that aspect. For that, there should be a base or as built drawings. So reality capture helps us to capture and then create a model based on the data that's been captured, and then from the model you extract the uh, required drawings. You can extract we can extract the floor plans, and then you sectional views and space, get the area, what is the area that is been available with me. So all these aspects, and then you now this will be a base for anybody to start managing this entire renovation projects. So that's about detail about the entire life cycle of the project. So how digital implementation can be done. So now coming back to, I'd like to give a little more brief on how why CD is important. That's a common data environment. So first thing is we have to set up a common or a strategy where you need to have a file naming convention, a structured file naming convention for all of them in the project to be followed. So that's something, this what I've displayed is a structured file naming convention as per ISO 19650. And then you have unique drawing numbers to be given. And then we have to set up a certain folders as per the standards. And each folder will have its own definition, and it's very clear that which folder has to be referred at what point of time, and which folder we have to we have to take the information from for the execution. So it's very important to set up this entire process so that everybody in the project knows what it is, and then where I have to get information from, and what is the correct information, all these aspects, and enforce this naming convention to the folder so that you don't have any other file namings. It is only the file namings that is being set up, and then you follow this file naming convention for all the aspects. Well, automate this to reduce the document control audits. So unless we give the right file name, the system doesn't take any of your files to this folders or to this common data environment. And this is something as I wanted to put it, because so this, you see traditional, I'm not judging it is a wrong process, but there's a betterment in what we can do from what is being followed. So if you take it, generally how things go around is we get a GFC drawings issued by consultants, and it goes to the construction site directly. So here, execution where you find some RFIs and it goes back to consultants directly. So if there is an error, or there's a collision between surveys, or there's a collision in some structure, so there's a lot of amount of rework or time that is getting wasted in this particular workflow. There should be one layer that has to be added into this workflow, is bringing this BIM aspect, that's constructability and space coordination review by the BIM manager. So this where you get the there we are only dealing with the drawings, and now here in this digital construction process, we need an 3D model, that's a geometric model with all the disciplines. And BIM manager actually reviews and the constructability and then space coordination with all the services, all the disciplines, and then make sure if it is all okay, and then clash free, and then good to go for construction. Then the drawings move to the construction stage, so which saves a lot of time, and then time spent on, because time is directly proportional to the cost here in for me, because when there's a delay in time, obviously we are spending more, and then it's directly proportional. So the amount of time we reduce and the amount of rework we reduce, it's all adding value to the project. So this is one technology or improvement that we need to bring into the industry. This is an automated process where we can resolve the or verify the model directly. So where you can bring in all the disciplines and then see how what reviews and then resolve all the collisions and spatial arrangements and all these aspects. This is some of the clash early detection of the potential. This might be occurring in the field, and then there would be a lot of change in routing or no time and all these aspects. So this has all been resolved at the early stages, and make sure there's no hiccups in the site during the execution. What you're seeing here is is a coordinated. It's a production area of one of the industrial projects where this entire services on the structure has been coordinated, and then clash free, and then the drawings have been sent to the site to execute. And it's after execution, it's updated as per the scan data, and then the model is updated as per the execution. So I was just putting this 4D aspect. I'll give a little more brief on how 4D will help any projects. It's basically you have a construction schedule, and then we are developing a 3D model, and then break down into this work breakdown structure that's in construction schedule, and link this each activity to the relevant 3D elements, and then validate the accuracy of the 4D model. So now we are very clear. So if there is anything missing that in the model that is not been attached, so we have missed out some planned activity in the schedule. So we update the schedule and make sure that we have included all the activities that has to be executed. And then say similar way, if there's anything that is been in the schedule and there's nothing in the model, so this we missed out modeling those aspects. So it's both the ways. You actually validate the model, and then we actually validate the schedule both, and then take this model and see virtually construction. So we virtually see the construction of the entire facility or factory that has been done, and see look at plans 3 months. Okay, what is the planned virtual construction? This much has to be completed. So you can have this look at plans along with the time. So when you add the cost element, then it becomes 5D, and then same thing has to be progressively updated during the construction phase, where we can bring in the actual executed work, actual dates, and then see what is planned and what is executed virtually. So we can virtually see this is what planned factory or facility looks like at this point of time, and this is being executed at this point of time. So what is the deviation? We, along with the reports, we'll be virtually seeing the model as well, so that there's a lot of transparency, and this helps us in taking the decisions forward. So how we have to allocate the budget, or and what aspects we have to push, and then get the things done as quickly as possible. So this virtual representation brings a lot of value addition to any projects. And this is an interesting, which I was telling, the construction progress monitoring, how the actuals have been brought. It is not just by looking and saying, okay, this much work has been done. It's again with using the reality capture. You capture the entire whatever been executed, and then compare it with the model, and then update. So along with the progress that we are doing, we can progressively update the building or a factory that is being executed, so that at the end of the stage, we do need to again start with from scratch. Okay, capture all the build all the factory, and then check with the model whether it is been executed as per, and then update. Instead of doing this activity at the end of this phase, on a progressively basis, keep updating the model throughout the project. So that's one. If not, if then this situation is, you have to at the handover stage, you have to actually we have to actually scan and then capture the existing conditions, and then update as per the site conditions. Because there's all this work that has been put in, finally this model has to be taken and then it has to be used for the entire operation So there's an enough value added because of the model during the construction phase, and the same thing, it has to be taken forward to the operation and maintenance phase, which is very important, because it is where it is a 1:5 is to 200, 1%. If you say one, if you're spending on construction, it's 5% for your operation and maintenance. So it is very important to take this model to operation and maintenance aspects. So some of the reality capture use cases that I wanted to put it here. So floor flatness using the point cloud, it's very important for any data centers or in or warehouses where the floor has to be leveled and it has to meet the certain requirements. So there's a manual inspection on the floor level, floor flatness, but again, it's might be not accurate. So there's a very digital and then very accurate measurement way this can be done. You scan this particular deck that where the concrete is being laid, or a floor, and then get the point cloud data from there, and then you extract the floor based on the points, and then give the reports based on higher elevation and lower elevation. So this basically, the scanner gives me an accuracy of 2 mm. So the amount of accuracy is high, and then we can get the entire coordinates of based on the spacing that you give every half meter. If we can get the coordinates, and these points can be given back to the survey team to work on if there are any higher elevations, or where there's attention or require a need for to correct those areas, or directly this as per ASTM standards. You can actually validate whether this whatever floor is being extracted from the survey floor scanning, so whether it is meeting the ASTM standards that is required, and whatever is being mentioned in the contract. So what is the floor flatness level and floor level, that flatness and levelness values have to be followed. So this can be added, and then you can extract the report whether this particular area does it pass through the standards or not. And these points can be overlaid on a drawing, and then see whether it can be which areas needs an attention aspect. And most of you will be thinking, what is scan to beam, and talking to on reality capture. I'd like to show it here, a small video how this scanning works. So this is basically a scanner. So this with the help of this, we capture the entire space. Then get an accurate detail of this point cloud data. This is a walkthrough of 360-degree view along with the point cloud data. And then extract, generate the model based on this data. You can add in all the non-geometrical information and set data, and take this model to the operation and maintenance phase. We actually generate the required drawing sectional views, quantity takeoff from the developed model. So this reality capture, where I was telling this for 4 stages: scanning, register, model, and deliver. First thing is, so it's a survey where we have to capture the existing conditions of the factory or facility, and then register all the data that is being captured to a single data, and we use authoring modeling tools to develop the model. And once the model is developed, and you can use it for various activities, like you can inspect with the present existing model, or we can get all the floor plans, sectional views, or quantity BOQs. All these there. Once scanning is done, there are plenty of use cases with this scan data. So that's one thing. And then this is what I was talking about, the field verification with point cloud data and VR. So the left hand side is basically manual measurement to check the dimensions, and it's not possible to check in every location, and and it might not be the accurate. So reality capture gives you an accuracy of 2 to 3 where you can actually measure the required dimensions to plan accurately. So these with the point cloud data, that's for some of the retrofitting, where we can wear the headset and walk through and see. This is what I was telling. If you wanted to plan something on a particular place, but we don't have the exact as-built drawing, so it's very important to know the dimensions. So this is the scan data, and we can actually wear the VR headset, or directly measure the distance, or measure the whatever the dimensions that you need to measure, and analyze whether certain things can be placed, or you can get an exact area of this particular place. So these analytics will help us in a lot of planning activities as well. So this will this is some last part of this webinar, where we're going to talk about what is digital twin. So as we are developing the model, so you have a physical asset, and then you are developing a replica of that physical asset, a 3D model. And then there are a lot of assets and then information that has to be added into this developed 3D model. So now you have actual building, and then you have a digital twin. That's a replica of your property or factory. So you have a digital factory now here, and this digital factory can be used for various activities throughout your operation and maintenance. This digital twin can be used for many space planning activities, or there's change in some aspects. So this digital twin is your base for your. So it's like an you cannot directly do anything with assets. So physical asset, you can actually do a lot of analysis with this digital factory or a facility that you have. So we have to add all the non-geometrical information or asset data that has to be fed into this model, and so that it is enriched. So it has all the details that is required for the operation and maintenance. So digital maintenance and asset management. So here we, as Despex, we are tied up with Gronlund Manager. We are partners with Gronlund Manager. Gronlund Manager is a cloud-based property maintenance and energy maintenance software. It is a well-established 40-year-old company who's been providing services on this, and then operation and maintenance. So this platform, so this is about you have a model and you have enough data, and this model is being taken to the Gronlund Manager. And this is static information that I have that is coming from this BIM model that has been developed. And there is some dynamic data that can be taken to this model, and which will be helpful for operation and maintenance. That's with the help of IoT, sensors and BMS, whatever data. And there's some customer consumption data as well, where electricity or heat or gas, if there's any complaints, and then water consumption. All these aspects can be brought in, and then set up the asset management and work on energy management and energy optimization. And there's a few reactive maintenance and preventive maintenance. There's a ticket raising system, where if there's an issue, you raise a ticket, and then that comes under reactive maintenance. And then preventive maintenance, we have already set up some maintenance plans or 52-week plans, where tells us what which activity has to be performed. So all these, and you have mobile based and then desktop user interface. It's very friendly user interface, and reports can be generated, standard reports, or you can integrate with Power BI to extract the reports as per the requirements. Basically, service request, yes, user can raise a service request, and then it will automatically go to the relevant person, and that person will address to this particular issue, and he'll have all the history of that particular, if take it as an equipment or a mission, if that he can actually see the entire service request or history of the service request and the maintenance plans, what it has been done, how many requests, what is the actual issue, why so many issues are coming in this particular. And this service request for QR code solution, it's not easy to give, say, if there's a big factory or some 3,000, 4,000 or 10,000. Recently, I visited a factory where there are 10,000 people working in that, and it's a 400 acre campus. So you need to have something very friendly and very easy way of service request system. So this is a QR code, each space or where the QR codes will be attached. And if there's any request, just you just have to scan this QR code, and then this will directly take you to the request, and then you add in the information, what is the issue, and select if there's any picture as well. And once the request is raised, the relevant person will receive a notification, and they can directly know at which location this issue is there, and what is the equipment, and what is the accessories that he need, or what is the quick process that he needs to follow. Everything will be there stored, and then it is easy for a person to just quickly address to that particular issue. And maintenance plans, so as you feed in the maintenance plans, and then schedule these as per the calendar, so that you get a preventive alert that this mission or this actually system needs an maintenance, and then audit whether what all things that has to be maintained and how it has to be maintained. Those documents also can be attached to this maintenance plan model. Then your mobile application, where a supervisor or surveyor who's managing this property will be able to access this. He will say, if this, like I was mentioning, this say 100 acre, 200 acre property, it's very important to know at which location and which system and what is the error. It's very important. So you can actually see it from the mobile. So where is this issue is coming from, and what is the history of this particular system or an equipment. So, and then you can address to this issue at an earliest. So some of the images from this, some case studies that I wanted to show. This is in a glass factory of old, which is they're planning to go with the renovation, and they don't have the present as built and then area and all these aspects. So we have captured the entire property and developed. These are scan data, how it looks like, and we have developed the model based on the survey that we conducted. So now, from the model, you can actually get the required information. We can generate the floor plans and then sectional plans and all the as-built data that has been required. We can generate from this. This is there's one more study that I wanted to show. So this is the point cloud data, and you can we can walk through this entire space, whatever we have captured, 360-degree image. Just by double clicking on the triangles, it's like a walkthrough of your entire property or factory. So basically, we can get the measurement directly from here, all the basic measurement that whatever is required. So yes, we can get all the sectional plans and all once the model is being developed, but we can actually refer to this scan data and do all the assumptions or analysis with the measurements here. And this is a rendered 3D model walkthrough of from the scan data and developed as-built drawings. So this would like to conclude this spoken a lot on digital technology, but I'd like to keep it as crisp and conclude what needs to be done and what are the areas that we need to focus as in construction. We all have to take this together and bring this digital transformation. So need for digitalization to cater the exponential growing complexity of system and infrastructure. This is very digitalization is what that we have to drive towards. And digital twin, yes, for all the managing facilities, digital twin is a mandatory that we need to take this forward. And then faster and efficient project completions using the technologies that we spoke about, and building facilities with operation requirements in check, yes, and then monitor construction progress and stick to plan schedules with the help of 4D and 5D and the reality capture. So validating the project deliverables and existing conditions for accurate management. So we need to have the accurate data, that is whatever is been built with the help of the reality capture technologies. And same thing for the digital existing buildings for further retrofitting or maintenance activities. So there has to be a model. If it is a old building, no worries. If it's 20 or 30-year old, we just need to scan and then generate the model, and then analyze the what is the strength and what retrofitting and what is the area that we have, what is the available no scrap, everything. So all this can be done with the digitalization. So I think I've taken too much time. We have very less time for the question answers. If, thank you. So if there's any questions, I would like to take questions. And before we conclude, in please visit our website. There are a lot of in insights. We have published a lot of case studies and explained in detail about our use cases. So if anybody is interested, can reach out to us on particular aspects where we have the lot of case studies which cannot be displayed everywhere. So we can just show and explain the case studies and use cases of digital technologies. So we have a few webinars that's been previously conducted. Everything is available, so you can refer to webinars, and there'll be more coming. A lot of interesting webinars coming up. Be following our page so you get on right information. So you can scan this QR code and reach out to our page and can follow. So it was great talking, and it was a great privilege to give on this very uh, because a very much needed things that we have to take this forward on digital aspect, digital transformation in AC industry. So if there's anything that you could reach out to Desapex, that's sales@desapex.com. So we would be happy to explain and take any of your requirements forward with the right digital solutions. So I'd like to thank everyone for joining, and it was great. And then if there's anything, you can reach out to us. So thank you so much.